It's my absolute pleasure to give you Randall Hunt. Woo!
Thanks, I got this one. All right, hi everybody. My name is Randall. I am a software engineer. Because I'm not really good at suspense, does anybody watch Game of Thrones? So you know in that one section at the end of every season where they just leave you on a cliffhanger and you're like, what the hell? Like, I wanted to see what happened. So I wanted to announce today that SQS for Lambda is coming very, very soon. So within maybe 1 month, you will be able to have SQS invoke Lambda functions, which is something that people have been asking for 4 years. 4 years externally, more than 4 years internally. So I've quit Amazon twice in the amount of time that, that I've been requesting this feature. So what I want to do today is talk about the evolution of serverless and how we came to be in the state that we are today. I want to talk about the current state of serverless on AWS. And then I was going to do some live coding, but that's really hard to do without a keyboard. So perhaps later, I'll record a video and I can post it online and I can show you what I was going to code. But typically, at this point in the talk, I ask people to come up with ideas, to think about serverless, and then refine those ideas throughout the course of the presentation. And in the last half of the presentation, I say, OK, now we're going to do some live coding. And I have people shout out ideas, and then we build something from scratch live on stage. I don't think that's going to happen today. So in lieu of that, I'm going to speak very slowly. And you can all fall asleep. I won't be offended. So a little bit about me. I'm a technical evangelist at AWS. That's just a really fancy name, meaning I'm a software engineer that they're allowing to go out and talk, which PR and legal have told me is something that they are against. This is my official badge photo, by the way. So what happened was, what happened in that photo was I rejoined Amazon. I came back, and they were taking these fancy new badge photos that have these like cool backgrounds and stuff, so they can do facial recognition when you're walking into the office. And I was all like, great, I'm so glad to be back. And then they told me that they had changed my original alias into something that was like Junior Hunt Jr., JR Hunt JR. And I burst out laughing, and then they snapped the photo. And then they were like, oh, we're so sorry. Do you want us to retake it? And I was like, no, it's perfect. So I spent a lot of time writing about our new features, about our new blog posts, about our new kind of cool things that happen within AWS. So I don't get a lot of sleep, given that we had 1,700 plus feature launches last year, and we're on course to do more than that this year. Keeping up with that is a full-time job, so I don't expect all of you to make that your goal. And I think Python is really, really nice, and I spend a lot of time on it. I worked on the async IO framework briefly. I was originally a physicist, but then I found out physicists don't make any money, so I became a software engineer. It's really cool. The easiest way to become a software engineer is you go to LinkedIn and you click Edit Title, and you change from physicist to software engineer, and all of a sudden your inbox is flooded with recruiters. This is a true story. Seriously, I was working at Mountain View at Ames Research Center at Moffett Field in California, and we hired this intern who was making $9,000 a month. It's like, what the actual, can I swear? Yes. What the actual fuck? This was in 2009, maybe? I don't remember. And like, unreal, right? So as a physicist who was like pretty accomplished given the fact that I was still an undergrad at the time, like, I was surprised that a software engineer who could not write like basic code was still making $9 grand a month. So I changed my title, and then all of a sudden I wound up working at this startup called MongoDB, which went public recently. The employee lockout on those shares ended, so I'll probably quit Amazon again pretty soon. I think that's wasted enough time. And when I say that I dislike JavaScript, it's not that I think that JavaScript is a bad language. It's that I know that it's a bad language. So that said, that doesn't mean you should not learn it. It's like a very useful skill to have. It's something that you should know so that you know how to not do other things. I think that we've all been overtaken by this mass psychosis, this like Stockholm syndrome with JavaScript, where we all think it's, it needs to be everywhere. And it is getting better. So that's the good news, is it's getting better all the time. So it's not like it's stuck in 2005 DHTML nonsense. We're getting better all the time with JavaScript. So I think like ES6 and all of the the cool things that are happening around there are really improving the ecosystem. But if I could sum up my thoughts on JavaScript, I would just say left pad, which crashed the internet. So I want to talk a little bit about the evolution of business logic within different startups and enterprises and corporations, and even mentally as software engineers. So let's go back maybe 1999, when we think of monolithic applications, maybe built on Spring, Java. And Spring is the first kind of platform to come in and bring in this dependency injection framework. They're saying you don't need to have everything at once. You can write these kind of structured services over SOAP. And SOAP is not like the stuff that we're supposed to use in the bathroom. It's XML, basically. And it's terrible, and it's awful, and it should have ended a long time ago. But it persists. Does anybody write Perl? I say write Perl because you can't read it. It's a write-only language. No, I love Perl, actually. So then we move into microservices. So we go from monoliths, we start splitting things out into microservices, and there are several advantages of microservices in that we're able to go and say, hey, I have distinct individual components of this that have a contract with other components of my ecosystem, and so long as we fulfill that contract, we can iterate internally on this service. It also has caveats, which is as soon as you break that contract, or as soon as you need to update more than one of these services simultaneously, the workload is increasing not linearly, but exponentially, because you're now having to manage complexity through a dependency graph. So there are downsides to microservices. And now we're in this phase of functions as a service, FaaS, which sounds like a goat. But really, it's just this concept of microservices applied to the fundamental unit of execution. And I don't mean like a processor instruction. I mean the fundamental mental abstraction of execution. So we have a goal. Maybe it's multiply. Maybe it's add. Maybe it's post tweet. These are all functions that we have of abstraction layers in our minds. When we think about programming, we don't think about, oh, I need to move this line here, I need to move this line here. Maybe you do in the beginning. It's like when you're learning to play piano, you're thinking about every single note. You're going and moving up and down, typing every single one. But as you become a bit more accustomed to writing code, you start moving around larger blocks of it in your mind. And there's a guy named Joel Spolsky who works at, or founded Fog Creek Software and Stack Overflow and all this stuff. And he coined this phrase of like your code radius. What's the amount of code that you feel comfortable modifying or creating from scratch? When you start out programming in college, maybe you're at 100 lines of code is where you kind of feel comfortable. You can maintain that in your head. Then you move to 1,000 lines of code, 10,000 lines of code, and then you become anti-res building Redis, and you write like 150,000 lines of code on a Thursday night, and then you're like, oh, I should go get the beer. So that's like the Jedi Master level. I feel like there are very few of us who have reached that, but it's something that we all aspire to. And you find that you build these deeper and deeper levels of abstraction, or higher and higher levels of abstraction that you're comfortable moving around. And that's what functions as a service is about, is like that fundamental unit of abstraction that I can have in my code that I don't need to worry about ulimits. I don't need to worry about execution state. I don't need to worry about the prereqs on the operating system or the libraries that exist on the operating system. I just want this task to be accomplished. And it's really, really powerful. Damn it. There we go. So 10 years ago, you would split monoliths by taking these giant XML blobs and sending them across either a network or even on the same machine sometimes as a communication medium. And it worked-ish. I think maybe I'll switch to the other clicker. There we go. And then 5 years ago, we get REST and JSON. And first of all, the fast binary encodings part, this is all provided by Protobuf, which is this really cool library that Google wrote a long-ass time ago that continues to improve and continues to be better all the time. And sending things over JSON works really, really well for JavaScript programmers, but when you have a large volume of data, it actually works better to use something like Protobuf and unpack things either locally or on the server side. That's not important, but This is what microservices looked like back then. We have all of this data flowing around, this dependency graph. You do have to eventually visualize this if you're a business manager in a large corporation. You need to know what all of your leaf nodes are, what all the dependencies on those middle nodes are. And luckily, we just launched a graph database, which I would not use for this, but that's just a fun thing PR wants me to say. The thing that Lambda first started out doing was kind of being this glue between all of these different services. It's just the business logic connecting core fundamental components, things like S3 for storing data, things like SNS for sending notifications, SQS for getting things from queues, Kinesis for streaming data, DynamoDB for non-relational database that you can only access by indexes that you swipe your credit card for. And API Gateway, which is a fairly expensive invocation method over HTTPS. And you can take that business logic and you can split it out into these little Lambda functions. Lambda functions is a really hard thing to Google, by the way, unless you've Googled it a lot and Google has learned your preferences. So good Google learning my preferences. But if you Google Lambda functions and you also have a history of working a lot in calculus and C-star algebras and stuff, then all you get is really esoteric and boring math papers. So don't study math. So microservices to ephemeral functions. We have this concept of these functions only run when they need to. So these aren't sitting around waiting to execute. These things are instantiated, these fundamental units of execution are instantiated just in time. That's a Java joke. They're available right when you need them, and then they go away again. And you pay whatever small premium you need to pay in order for that convenience, but you also end up paying a significantly lower cost in the gross majority of workloads. Even if you end up paying a greater cost in some workloads, the increased agility of being able to make changes and deploy in these smaller fundamental units is most of the time worth it. Not all of the time. I gave the keynote at PyCon Web in Munich a few years ago, and I actually did an analysis, a breakdown of where do things fall short. So if you look at a typical 3-tier web application, you have maybe a Nginx proxy fleet or a load balancer or something like that. You have Flask or Rails or Django or Tomcat, whatever kind of underlying web engine you want, and then you have your data tier. So maybe you have some caching in there somewhere. You have some HA proxy stuff going on, Elasticache. And when you have these kinds of applications, they're fixed cost. The load balancer is what I would consider a fixed cost. Yes, it can auto-scale and you can provision more capacity as needed, especially with application load balancer, but it's still going to be a fundamental unit of cost at the minimum. And then you have a fundamental unit of cost, which is the monthly server cost. And yes, that can auto-scale. You can add more instances as you need to. And then you're going to have a fundamental unit of cost on the RDS side, on the database side. These are all fixed costs that are only going to go up. They're never going to get smaller. So the advantage of something like Lambda and non-relational data stores and kind of these access over HTTPS mediums, and also Aurora Serverless. Has anybody heard about that? So Aurora Serverless is basically your database scales down to 0, and it has a warm pool of units that scale back up. I was going to demo that briefly today, but find me later. I do drink beer and coffee, so both of those things are acceptable bribes. If you want to get into previews that you're not in yet. So when the system's down, when you're not running anything, you're not paying anything, and this is a huge advantage. Except API Gateway is still kind of expensive. So what does serverless mean? It means never pay for idle. It means you're not having to provision or manage anything. It scales with usage. Does anybody know Snapchat? OK, does anybody use Snapchat? OK, so we are all adults. So my niece uses Snapchat, and I use Snapchat to communicate with the younger cousins in my family. And by communicate, I mean constantly question what the hell is going on in high school in America these days. And there's a really cool thing about Snapchat. They talked about this at reInvent in 2017, where they scale from a couple 100,000 requests per second up to 5 billion requests per second on New Year's Eve. So right when New Year's Eve hits in places like New York City and Sydney and all these different places, they go from almost nothing, or well, not almost nothing, like significantly high volume of requests that any of us would be very happy to have if our app was viral. But they go from a base layer of request up to 5 billion requests per second. Has anybody ever worked with a system that does 5 billion requests per second? Okay, I did once, and the entire time I was just like, oh God, oh God, oh God. And like my pager didn't stop going off for like 72 hours. And eventually I just threw it in the garbage disposal, and it doesn't blend. So I strongly suggest checking out this talk because it talks about how you can take DynamoDB and go from 100,000 transactions per second to 5 billion transactions per second over the course of, I don't know, a couple minutes, and then go right back down. And they also make use of a number of other cloud providers. So it's also a cool story about using the best tools that each cloud provider has available. And there are arguments about buying into different ecosystems and stuff. And I fully believe that if you have enough money, you can buy into all of the ecosystems, and everyone will be happy to have you. But if you don't, it's probably best to focus on a set of core competencies within your team, whether it's Google or Azure or what is ours called? AWS. I don't care. Like I said, I'm not a salesperson. I'm just an engineer, and I like it when people use the best tools available for the job. That said, when it comes to Lambda, I do think that Lambda currently is one of the best functions as a service offerings. And my reasoning behind that is objective. So the offerings from Azure and the offerings from Google are differentiated. They have different invocation paths. They have different performance paths. Actually, the best place to run .NET right now is on a Lambda function, which is surprising. But that doesn't mean it's always going to be that way. So if you're a developer, it makes sense to go out and learn the different kind of execution mediums for functions as a service. So just because you know Lambda doesn't mean you don't need to know Google Cloud Functions, doesn't mean that you don't need to know Azure's Event Grid. Like, you should go out, take the time, do the research and development as an individual to be able to process all this stuff and pick it up. And then when you come back to Lambda, very happily, I will be here to help you do that stuff. So what does it look like? You have an event source. These event sources are myriad. There are thousands of different event sources. Everything on the internet that's a webhook could be invoked, could invoke a Lambda function. So Twitter just launched their account activity API. Has anybody followed this at all? Okay, it's a catastrophe. I mean, Twitter is basically a dumpster fire anyway, but does anybody work for Twitter? Because I got a bone to pick with you now. There's this issue, right, where they switched from their streaming API, essentially these long polling APIs, into these webhook APIs. And these webhook APIs are great, right? It allows us to do this stateless execution. It allows us to say, okay, well, now whenever I get a new tweet, or I get a new follow, or I get a new event, I'm going to have my Lambda function run. Except it sucks. It doesn't work. They have a really great design and a really bad implementation. And so I have a whole talk about webhooks that I'd really love to give, but it's not available today. So the thing is, all of these event sources are just ways of getting to your business logic. And your business logic is your differentiating factor. So if you're selling pictures of cats on the internet, there's not a very differentiated business. But if you're selling pictures of cats eating cheeseburgers with hats, riding a unicycle on the internet, that's somewhat differentiated, but it's still pictures of cats. And you want to figure out how you can modify your functions, how you can add in the logic into your functions and the execution into those functions to be able to differentiate your business. And that's when you get out to what the function is doing. And the function, what it's doing, is basically anything. It's just code. If we can do something in code, we can do it in a Lambda function. There are really no limits, aside from 3 gigabytes of RAM and 500 megabytes of temporary storage and 5 minutes of runtime, 300 seconds. Anybody figured out a hack to get around that yet? Again, buy me a beer later. So I really like the idea that I can bring my own code, whether it's Node.js, Java, Python, C#, Go. I can build my own libraries. If I want to run Rust, if I want to run Perl or whatever, anything that's libc executable, I can basically go and say, hey, let me run this. I have synchronous invocations. I have asynchronous invocations. It's integrated with all of the other AWS services. My CPU scales with the amount of RAM that I provision. There's actually a guy named Alex Casabloni who just joined my team at AWS. But previously was like very big in the AWS Lambda ecosystem and serverless ecosystem, and he wrote something called AWS Lambda power tuning. And power tuning works by, sorry, I'm just checking my time. Power tuning works by actually creating aliases of your function, and it will run those aliases with 128 megs all the way up to 3 gigs of RAM, and it will do power tuning. So it will figure out which one is going to complete fastest and which one is going to complete the cheapest. So your intuition may lead you to believe that if you provision the least amount of RAM, then it'll be the cheapest. But that may not necessarily be true, especially if your task is compute bound, right? So you might actually have a faster completion and therefore lower cost wherever that differential fits in. If you go right up to 3 gigabytes. So if your function completes in 100 milliseconds as opposed to like 10 seconds, it's going to be cheaper. Cool things to think about. And then, of course, it works in VPCs and IAM, which is identity and access management, which is typically the #1 thing people ask me about on Twitter. It's in JSON. And I think we all know how I feel about that. So the permissions model for Lambda is really straightforward. Does everybody know this already? Can I skip it, or do you guys want to learn about it? Because I'm not sure. Who here has already deployed like a full-scale application to serverless in Lambda? Okay, and who here is learning about serverless? Oh, well, that was not a discrete set. So let's cover this then. So there are kind of 2 different security controls within Lambda. You have your execution policies, which are what are the things that are allowed to invoke this function? Who is allowed to sorry, you have the execution policy, which is like, what is this function allowed to access? And then you have your function policy, which is used for saying, these events can trigger this function. So here's an example. You have a synchronous execution, which is an API gateway, that is calling out to an endpoint /order /picture of cat, get, post, whatever, and it's invoking a Lambda function. And this is synchronous in that the Lambda is going to return the response. Then you have asynchronous invocations through things like SNS and S3 that basically have some internal magic happening that are going to invoke the Lambda function asynchronously. So it's not going to wait for a response from the Lambda function before moving on to the next invocation. If you want an example of this, does anybody take selfies? Okay, if you go to github.com/AWS Labs/selfies analyzer, I built an application. I'm a millennial, so I take selfies, I guess. What is a millennial cutoff? I want to be a millennial, so I'm taking lots of selfies. So we have a service called Recognition, and Recognition does some deep learning on image captures. So it can do face analysis and emotion detection, and whether or not you're wearing sunglasses, it can tell you if you look like a celebrity. I know I look exactly like Dustin Hoffman, and I'm glad you all agree with me. And I know that I'm also 43 years of age, according to Recognition, which is kind of like, you. So I really want to retrain that data set. But you can get some really cool insights on it. And basically what happens is I have a thing on my phone that syncs my new photos and my camera uploads to an S3 bucket. As soon as they're uploaded, they get tagged in, with Recognition with all of the different things. And then I download them back, and those tags get converted into OSX tags. So when I search for receipt image or selfie on OSX, it will show me all of the receipts that I've taken on my trip to New Zealand, which so far has been 0, because everybody keeps paying for me. Thank you. And then we have stream-based invocation. And stream-based invocation is a lot of fun. You can really knock down some websites. I mean, you can really do some cool stuff with stream-based invocations. And these are things like DynamoDB streams or Kinesis streams, which are basically the same thing, that invoke Lambda functions and perform some action. And you can choose how you want that invocation to happen. You can have like both the old image and the new image, or you can have the the latest record, or you can go all the way back to the beginning of time, and these records will keep retrying indefinitely or until they age out. So it's pretty useful in case something goes wrong, like US East 1 goes down. And then when it comes to authoring Cloud functions, and when it comes to authoring Lambda functions, you have Cloud9, which I wouldn't suggest anybody use, especially if you're on an airplane. It is really useful if you have a potato computer. So if you have like a MacBook Air or something, Cloud9 is dope. If you have a real computer, you don't need Cloud9. There are advantages to Cloud9 in that it has built-in access to all of your kind of underlying infrastructure. So if you provision it within your VPC, you now have access to those resources. So you can do and develop in things live. There's also VS Code, which I've been playing a lot with lately, which I think is really, really good. And Cloud9 also has a couple of built-in editors. So Cloud9 is based on an acquisition that we had back in 20 year. And we basically took this company in Amsterdam and we were like, hey, we really like your products and we're really aligned with your values, and we became best friends. And then we published Cloud9, the editor, which is basically the ACE open source editor with an entire IDE around it. The best part about it is that it has Vim key bindings. It also has Emacs key bindings, but I have a Grease Monkey script that will remove those for you if you want to not have your environment polluted. I guess everybody here is an Emacs fan. Oops. Did not read the crowd correctly. So the programming model for Lambda is the same as running on anything else. Essentially, you have processes, you have threads. If you're using Python, you don't have access to things like multi-processing, certain semaphore libraries, just because they rely on components that aren't really available in Lambda. But you have some temp space, you have limits, like I think you can only make 1,024 concurrent connections or something, and you have the AWS SDK already built in and provided for you. And the cool thing in Python is that you also get requests for free through the Boto SDK. You have really good metrics and monitoring and all kinds of good stuff that I think you'll hear about later today. Probably at the very end of the day, you'll hear about X-ray and step functions and all kinds of good stuff like that. So what does it look like? You have a handler function. You know, I'm passing in a book, or I could pass in an event, and then I have the execution context. The execution context has everything that I need. For instance, the amount of time that I have remaining in my function. For instance, if you're crawling websites for stock tips, you can just constantly call, you know, time remaining millis on the context object in the end of every iteration of your loop. And then when you do run out of time, you just say, oops, and you pipe it all out to either S3 or Dynamo or whatever, and then you start a new function, and that's how you get around the execution limit. Very expensive to do that, by the way. Don't do that. So one of the best parts about working at AWS is that I do not pay my AWS bill. I just get increasingly urgent messages from my boss, like Randall. And it's when it gets to like 5 exclamation marks that I know I should probably start shutting some stuff down. Luckily, we also have a bunch of like built-in stuff for managing budgets that are actually available to all of our customers as well, which is pretty cool. And again, you have all of these different data sources: S3, DynamoDB, Kinesis, Cognito. Cognito is really cool in that you can do pre-roll and post-roll. So Cognito is a service that we have it's like an OIDC. It's essentially an identity provider. So let's say you want to log in with Facebook, or you want to log in with Twitter. You want to well, no, not Twitter, because Twitter doesn't conform to the actual OAuth standard. Anybody that actually follows a spec, you can go like LDAP or SAML providers, Auth0, Active Directory, like all of these different specs can come in through Cognito, and you can have that authenticate your apps. The other advantage is Cognito has built-in integrations with API Gateway, and it also has built-in integrations with ALB. So if you're gonna go the server route, you can actually use Cognito to authenticate sessions that are coming in over your ALB. And I just wrote a blog post about that if anybody wants to talk about it or read it. Ding, it's the PR thing again. So when it comes to invocations, the data store section is really, really cool. But the other cool thing about Cognito is you can do pre-roll, post-roll, and also like maintenance using Lambda functions. So let's say every 30 days you want to make sure that the user's password hasn't been posted to like passwords pwned or something, which is like this thing that Troy Hunt made where you can look for passwords that have been posted on blacklists. And you can have a Lambda function that runs on a schedule that goes and looks through all of these salted passwords that are already salted and encrypted, and you can just post those to Troy Hunt's database, and he will tell you whether or not it's been posted somewhere, which is pretty cool. So you never have to have the plain text of the password. Cognito also has features where you can go and say, okay, whenever a user signs up, I want to be able to, it's really hot, I'm gonna take this off, sorry. Whenever a user signs up, I wanna be able to send them a message with like SNS or with simple email service. There's also a thing called Pinpoint, but that's really just for marketers, it's not for developers. I mean, it has an API, but has anybody seen the Pinpoint API? Yeah. Do you have any thoughts on it? Oh, well, I'll summarize my thoughts on it. It's horrendous. It is like what happens if you have a REST API designed by a intern who has never written anything but Java and has never seen a REST API before, but it's only had it described to them in German and they only speak Dutch. That's how I would describe the Pinpoint API. Luckily, we know these things and we're making it better all the time, and we get great feedback from customers who do use the product. And the console is really nice. So then you have CloudFormation, you can have custom resources, you have CloudTrail, you can have things that are gonna go and make sure that when certain actions happen within your account, you can respond to them programmatically. You have code commits, so when these are like post-commit hooks or post-receive hooks on GitHub. You have CloudWatch, where you can have different alarms and dashboards and all that good stuff. SES again. In fact, if you email credits at randman.com right now, you will get $100 AWS credit code. I'll type that out later. And then the other advantage of Lambda is that it's really fine-grained pricing. So we thought that millisecond-based execution pricing was going to be a big deal, except then we released the Go runtime, and the Go runtime completes in sub-millisecond executions. So got to rethink that one. But for everything else, there's millisecond execution. So you buy compute time in 100 millisecond increments. The lowest request charge is that 100 milliseconds. There's no minimums. There's no like charge. Then you never pay for idle. And you get 400,000 gigabytes per second of compute for free every month and 1 million requests. So to give you some idea about how valuable this is, I used to run a website when I lived in New York called isthe7trainrunning.com. And the answer was always no, but occasionally I did ping the MTA, which is the Metropolitan Transit Authority API, just to make sure that it was no. And this site, when I ran it on Elastic Beanstalk, would cost me like $7 a month for like 40,000 monthly active users. When I switched to Lambda, it went from, I think it was $7 a month down to like a cent a month. And the cent a month was mostly for CloudWatch and logs. It was not at all for, because I was already over my free tier limit on CloudWatch because I had a bunch of other stuff running. But the whole cost was tiny. So again, you can use it for web applications, backends, data processing, chatbots. This is my primary method of communication with my family now. Alexa, and IT automation. So I sense after this presentation that it will be the only way that I'm allowed to communicate with any of you. When Amazon Legal and PR review this, they're going to be like, oh, crap. Let's revoke his speaking privileges. So when we get into IT automation, I gave a talk about this at reInvent back in again, I'm really bad at years, but a few years ago, I gave a talk at reInvent about creating IT policy engines. So I worked at a company called SpaceX that had some very, very strict evil government overlords that wanted us to adhere to these really stupid laws that made no sense and were basically just bureaucracy so that some fat cat could get paid for doing nothing. And in order to comply with those things, we had to build out an automation engine. And we did this in GovCloud and in US East 1 and in a couple of other places. And the downside of doing that is that auditors don't know what the hell they're doing. And so they come in and you're like, look, I have this automatic system that will make sure nothing ever goes wrong. And they're like, we don't believe you. We need you to hire 3 full-time engineers to review this every day. It's like, crap. Thanks, auditors. So don't go into the space business. Then we get into API Gateway, and I'm going to speed along here. API Gateway is a really, really nice way of providing a little HTTPS. It's basically like, anybody have like a giant reverse proxy fleet for their service? You should. This is a good way of like not going down. So API Gateway is basically a giant reverse proxy fleet auto-scaling for your service, where you create a unified front end and you have these. Does anybody remember velocity templates? Okay, so Java and Apache met in a room one day and they decided what's the most convoluted and awful templating language we could come up with, and they came up with velocity templates. And velocity templating language is basically where dreams go to die. If you've ever wanted to slam your head into your desk for an hour, try the velocity templating language. And that, of course, is what we chose for transform requests within API Gateway. It is actually not that bad. It's pretty powerful. You can actually do a lot of calculations and OAuth stuff in the velocity template. So if you have to calculate a checksum or something or a CRC, you can do it in the template. And you can make API Gateway do that work for you for free. You can authenticate and authorize requests to your backend. Of course, not with Twitter, because Twitter requires you to read the entire body of the request. Just a quick note here for the more advanced users that you have, when you do an authentication custom authorizer in Lambda on API Gateway, you only get access to the headers. You don't get access to the body. So if you have to calculate like a whole checksum or something based on the body of the message and some secret key, you cannot do that with a custom authorizer, which is frustrating. And again, it has built-in throttling and metering, and you can even monetize your API based on the API key that's coming in. You can track requests. And the DDoS protection is really, really good when you piss off a bunch of Trump voters. Funny story about that. Again, beer. So I'm just going to skip ahead a little bit. Again, I kind of covered the custom authorizers, Cognito user pools, and stuff. There are a couple different authentication types that I was talking about earlier. You have AWS IAM. No one really uses this except for us internally for all of our services that are built on top of API Gateway. If you want to use this, there are advantages to it. The IAM standard for signature signing is actually really, really well thought out. If you'd like more detail about that, I'd strongly suggest reading or listening to Eric Brandwine's talk, A Tale of Two Encryptions. And it might have been called like, it was the best of encryption, it was the worst of encryption. It was a Charles Dickens joke. It is a very, very powerful request signing method. So I do recommend it, but no one uses it. So let's move on to the things that people do use, which are token authorizations. And this is the typical thing that you will see in most mobile apps. You have request authorization where they're going to pass in some custom header, and you're reading off of that header and signing it. You have Cognito. And Cognito is basically the same as the request, except it's doing its own magic on its own backend. Magic being a hand-wavy term for request signing and authorization and all that good stuff. Cool. And then you can send back custom responses. You can do throttling. The token bucket algorithm is how you can say how many requests are allowed to get through right now. I don't really have time to get into that. I just added a bunch of slides in at the last second because I realized I wasn't going to have my computer to type. So this is my fault. But also, computer typing would have been nice because I would have switched to the live demo at this point. You can run your APIs within your own DNS zone. This could be a private hosted zone even. So it doesn't need to just be a public API. It could also be a private API. You can also have APIs that are in individual regions instead of edge optimized. So the typical deployment method is edge optimized, which means it's basically fronted by a CloudFront distribution that's deployed to all 100 of our POPs, or 100 plus of our POPs, on 100 plus of our edge locations that are all connected by Amazon's global backbone, which is like a 25 gigabit per second, 40 gigabit per second sometimes, backbone that's global and travels over our private network, and boom, you invoke it, ta-da-da, you get your request. There's also Lambda Edge, which is something I should have talked about earlier. Lambda Edge is super cool. The only downside is that it only supports JavaScript. But Lambda Edge is this idea of running functions at the edge. So this is running functions at a POP, at a point of presence, at an edge location. And there are companies who have moved their entire infrastructure onto Lambda at edge. So you write the function US East 1, and then you say, oh, I want to make this an edge optimized function, and then it says, well, you have to complete in less than 30 seconds, and you have to have less than 1.5 gigs of memory, and you can only use Node. And you can redeploy your entire application on this edge optimized Lambda, which is really, really powerful. Cool. So these are a couple of examples. This is the first This is the first example I talked about, which was you put an object in an S3 bucket, that invokes a Lambda, that Lambda does something. If you want an example of this, if you go to twitter.com/AWS Cloud Ninja and you post a selfie, it will replace all of the pictures in that face with AWS Cloud Ninjas. Then you have data is published to an SNS topic. So this data could be something like, Randall, get off stage. And that SNS topic would be like people hating on Randall, and it would invoke my Lambda, and my Lambda would be like, no. And then we have the SDK clients, and these are allowing you to invoke the Lambdas directly. So you could do this in Java, you could do this directly from your code. So let's say there's this really cool framework in Python called PyRen, that allows you to basically abstract out, like you add a decorator on a function and it moves that function into a Lambda function. So let's say you have a piece of computation that needs to have access to some local resources. And not local resources, some resources in AWS. And you want to run the script locally. So you can have this decorator on top of this function and it'll go and it'll invoke the Lambda function, either synchronously or asynchronously, and then return as if it were just going through the regular execution. Then we have CloudFront that can invoke Lambda Edge functions. We have step functions, which hopefully you will hear a lot more about later today. We have API Gateway that can invoke lots of functions. You have API Gateway that can invoke step functions. API Gateway can also invoke directly to Kinesis and DynamoDB and many of these other kind of services. It can just be like a front for those. And then you have also calls out to like, oh, I just said what those were. So. This brings you to the question of, do I need one function? This is called the monolithic function, or do I need many functions? And this is a problem that everybody faces on actually all of the different platforms. And I have the answer. And like, I genuinely do have an answer for you. I know people come on stage and they're like, oh, this is the best practice. No, this is what you do. OK, so if you have an existing application and it fits in a function, make a monolithic function, and then wait for something to go wrong. And when something goes wrong, you take the part that went wrong and you move it into its own function. Repeat as necessary until you are no longer a monolith and now you are microservices. This is how I have ported every single demo that I've ever built. Every single production service that I've ever built has been ported in this way, and it has not failed me. It's failed some of my customers. No, I'm teasing. But genuinely, this is a tried and true method for getting stuff done in serverless, is if you have an existing application, go out and just say, let me put this into a monolithic function, and then I'll extract out maybe the auth bits, maybe the microservice bits. This brings another question to mind, which is, who here thinks that authentication is a microservice? OK, so you're all wrong. For the purposes of any video, it was 100% of the audience. Everybody was very enthusiastically raising their hand. Auth is not a microservice. Auth is a macro service. Login is a microservice. Logout is a microservice. Send new user password is a microservice. So when you think about these things, you really do need to get down to that fundamental execution unit, that fundamental business unit, which is a word I'll probably say like 500 more times before you guys kick me off stage. Am I out of time? Damn. I've been going as slowly as I could, so. We'll skip through some slides here. OK, yeah, so here's a quick announcement for everybody. I gave it away in the beginning, but we are very soon going to have SQS as a means of invoking Lambda. Now, this is really, really cool. I've only been asked, so I had the product manager for Lambda is AJ Nair, and I've known him now for a very long time, and I told him I would name my firstborn child Lambda or Tim, or Wagner, or AJ, or whatever they wanted, or Sam, so long as they would get me SQS going into Lambda. And now that they're fulfilling this, I have to, like, very quickly, like, yeah, but the Mythical Man Month doesn't work like that. So, like, I need to figure out a way to like, make them later than I am. So, if anybody has any, like, suggestions for how to delay this feature, let me know. So SQS is an invocation source. It's coming very, very soon. I'm writing a blog post about it currently, and this isn't on the internet yet. Well, except if you look at the AWS documentation where we accidentally published it early, which is one of the things that I wanted to share with you today. There are a couple of other announcements that I was hoping to share with you, but given the time zone, I have not gotten approval. But talk to me again a little bit later in the day. And I think that's the end of my slides. And we should probably unplug the screen just because people shouldn't see that. Yeah. And I don't know who's up next, but I think you're hearing from some folks at Google next, and I think you might hear some folks at Microsoft later today. I just wanted to reiterate my point. Like, you really should learn about all of the different providers. You really should, as a developer, try your best to maybe not become an expert, but know the fundamentals of each one of these different execution mediums. And Lambda has been doing this for a long time, since 2014. And I remember sitting in the audience at reInvent in 2014, and there was one half of the audience that like immediately got it. Like, these are the people who had been using Yahoo pipes and Hooks.io and Iron.io, which was this other company that made this available in the beginning. And you could see like that portion of the audience got it. And then over here on this side was like the press corps. And the press corps was like, what the hell is this? Like, why is everybody clapping? And it was just like, whoosh. And then in 2017, when I was at reInvent last year, no one in the press corps was asking, what the hell is Lambda? No one was asking, what is serverless? Everybody was asking, how can I use more of it? And it's not, how can I use it? They're already using it. They're asking, how can I use more of it? So I think we're in a very interesting time and a very exciting time where we have a paradigm shift. You know, we had paradigm shift from like relational databases to non-relational databases, back to relational databases. But right now, we have a paradigm shift from these monolithic kind of hunks of code running on containers somewhere into these abstracted functions as a service. And I think that abstraction and that paradigm shift is going to stick with us. And I've been wrong before, but I'm probably not. So it is worth it for all of you to be here. I wanted to say thanks, everybody, for coming here. You're really making an investment with your time to like learn about this. And I hope my talk was less boring than it appears. Thanks, guys.